Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain and in today's lecture we will start coordinate geometry of class 10th. In class 9th you have studied some of the concepts of coordinate geometry, right? So we will revisit those concepts and then we will continue with the syllabus in class 10th, right? So you should be aware by now that these two mutually perpendicular lines, right? Let's say this is a horizontal line and this angle is 90 degrees, right? This is vertical line. Okay, these two mutually perpendicular lines divide the entire two-dimensional space. What is a two-dimensional space? For example, this board, the paper that you are studying on, right? Any two-dimensional space will be divided in four parts by these two mutually perpendicular lines, right? First part is this, second this, third, fourth. Four parts, right? This horizontal line is known as x-axis and this vertical line is known as y-axis, right? And this point of intersection of these lines is known as origin. This is denoted by O and this is called origin, right? And the coordinates, what are the coordinates? For example, let us say, let's mark these points here 1, 2, 3, 4 and so on, and this is the negative side of x-axis, -1, -2, -3 and so on. This is positive side of y-axis, 1, 2, 3, -1, -2, -3 and so on. So what are coordinates? Let us say you want to reach some point here, right? So how do you define that point? You define that point by how much distance do you have to cover in this direction, and then how much distance you have to cover in this direction, so you can reach this point here, right? So if I say the coordinate is 3, 4, right? This is how you denote the coordinates. In this bracket you write 3. Let's say this is your first coordinate, which is x coordinate, and this one is y coordinate. So 3 here is the x coordinate, 4 is the y coordinate. So how will you reach at a point 3, 4? You go 3 steps in the x direction and then 4 steps in the y direction. Then you reach this point, which is known as 3, 4, right? So this is how you locate a particular point in two-dimensional system using the coordinates. Now we have already discussed that this side is the positive direction of x-axis, this side is the negative direction. This side is the positive direction of y-axis, this side is the negative direction of y-axis. So let me make this diagram once more. This is x, this is denoted by x dash, this is y, and this is y dash, and this is O. The coordinates of origin are always 0, 0, right? And then on this right hand side you see that the coordinates are positive, 1, 2, 3, 4 and so on, and when you go upwards the y coordinates are positive. So any coordinate in this quadrant, right? We have discussed that this rectangular coordinate system divides the entire two-dimensional plane in four parts, right? These parts are known as quadrants. For example, let us say these are the quadrants. This is x, x dash, y, y dash. So these are four parts, right? These are known as quadrants. This is known as first quadrant, this is second, this is third, this is fourth, right? This much was discussed in class 9th also. So in the first quadrant, what will be the sign of both the coordinates? X coordinate will be positive, obviously, because in the first quadrant if there is a point, let's say this point, you have to go to right on x-axis, let's say here, and then you have to go upwards to reach this point, right? So both the directions are positive, so x is also positive, y coordinate is also positive here. But if there is a point in this quadrant, you'll have to go towards the negative side of x-axis first and then towards the positive direction of y-axis to reach this point. So the coordinates of this point are negative and positive. This is x coordinate, right? So you have to go to the negative direction of x-axis, so this is negative. You have to go towards the positive direction of y-axis, so this y coordinate is positive, right? So in every quadrant we can define that both x and y coordinates are positive in the first quadrant, right? In second quadrant, x coordinate is negative, y is positive, right? Because in second quadrant, if you want to reach at any point, you have to go towards negative direction of x-axis and then positive direction of y-axis. So negative, positive, right? So you tell me what will be the coordinates in third quadrant? Negative, negative, right? In fourth quadrant, x is positive and y is negative, right? So this is the sign convention in 4 quadrants, right? So this x coordinate, let us say there is a point 3,4 once again. This x coordinate is also known as abscissa, and this y coordinate is also called ordinate, right? So let me ask you, if there is this point, what will be the abscissa? Whether the abscissa will be negative or positive? Obviously negative, because to reach this point you have to go towards negative direction of x-axis. So the abscissa for this point, abscissa will be negative, right? And what will be the ordinate? Ordinate will also be the negative, because you have to go downwards in y direction, right? So ordinate is also negative, right? So by now you should be able to understand how to locate a particular point in two-dimensional system. What is a two-dimensional system? This is also known as rectangular coordinate system, rectangular coordinate system, or it is also known as Cartesian coordinate system, Cartesian coordinate system. So you know how to locate a point. You go towards the x direction and then you go towards the y direction and then you reach that point, right? Second thing you understand is how this coordinate system divides the plane in 4 quadrants, and you know the sign of coordinates in all the quadrants: positive, positive, negative, positive, negative, negative, and then positive, negative in the 4th quadrant, right? Now we will calculate, let us say, the distance between any 2 points in the Cartesian coordinate system. Let's say these are 2 arbitrary points, any points in the coordinate system, x1, y1, and let's say this point is x2, y2. Let's give a name to these points, A, B. Okay. Now you need to calculate this distance AB, right? So to calculate this distance AB, what you need to do is, this is x-axis, this is x dash, this is y, y dash, and this is origin, right? Now if I drop a perpendicular from this point A on x-axis, right? So what will be the length of this perpendicular and what will be this distance? If the coordinates of this point are x1, y1, so obviously this distance is x1, right? So to reach this point you have to go x1 distance in x direction, and what will be this point here? It will be y1, right? This distance will be y1. So this point is 0, y1, and this point here is x1, 0, right? And if I drop a perpendicular from B to the x-axis and to the y-axis, what will be this point? This point will obviously be x2, 0, right? And this point will be 0, y2, right? So I need to calculate the distance AB, right? If I make a triangle like this. I draw this line parallel to the x-axis and this line is parallel to the y-axis. So obviously this angle is 90 degrees, right? If I now ask you, what is this distance? This distance is nothing but, if I, let's say this distance is x2, right, and this much distance, this much is x1, right? If I subtract x1 from x2, I'll get this distance. So this is x2 minus x1, right? So I can say that this side of the triangle is x2 minus x1, right? So what will be this side? This distance is y2, right, and this distance is y1. So this will obviously be the difference of these distances. So this distance is y2 minus y1. Now if you notice, if let's name this point as C, okay, if you notice in this triangle ABC, C is 90 degrees, angle C is 90 degrees. So we can apply Pythagoras theorem in this, right? So AB square will be equal to BC square plus AC square, right? We are calculating the distance AB here, right? So AB square will be equal to, what is BC? BC is nothing but y2 minus y1 squared, and AC is x2 minus x1 squared, right? So what is AB? AB will be equal to square root of x2 minus x1 square plus y2 minus y1 square, right? We have not considered the minus sign. When you take the square root, there is a plus minus, right? We have ignored the minus sign because we are talking about distance here, right? And distance cannot be negative, right? So AB is x2 minus x1 whole square, y2 minus y1 whole square, right? Even if you write it like this, if you write it x1 minus x2 whole square plus y1 minus y2 whole square, it will still be the same. It won't make a difference because there is a square, right? x2 minus x1 or x1 minus x2 won't make a difference, right? Because when you square it, the negative sign will obviously become positive, right? So you can write it as like this. This is nothing but difference of abscissa squared plus difference of ordinates squared, right? So this is the distance between 2 points AB, right? So the distance between 2 points is difference of abscissa squared plus difference of ordinate squared and then square root, right? So let us say you need to calculate a distance from the origin to any point, let's say xy. You need to calculate this distance. Distance from origin of this point, let's say this point is P, right? And origin is denoted by O. So you need to calculate distance OP. What will be distance OP? Difference of abscissae x minus 0, right, squared, plus difference of ordinates y minus 0 squared. So it will be root of x square plus y square, right? So if you have to calculate distance of any point from the origin, you simply square the abscissa and ordinate and then add them and take square root. For example, you need to calculate distance of point 34, distance of point, this is point 34 from origin. What will be the distance? It will simply be 3 square plus 4 square square root, right, which is 9 plus 16 square root equal to 5, right? So this is how you calculate distance from origin. Okay, I hope the distance formula is clear by now. So let's discuss some of the concepts of geometry that you have studied in class 9th. right? These will be used in this chapter, the upcoming exercise, right? And we will use distance formula to prove those results, right? For example, test of collinearity, right? Let us say there are 2 points A and B. 2 points are always collinear. You don't have to prove anything in that, right? Any 2 points, there will be a unique line passing through those 2 points, right? The challenge is when the third point comes. Let us say there is third point C. This is A, this is let's say B, and this is let's say C. Now you need to prove whether these 3 points are collinear or not, right? So look at this. If these points are collinear, right? Let's say these points are collinear. What will happen is this distance AB and this distance BC. If you take the sum of these distances AB plus BC, it will be equal to AC, right? If these 3 points are collinear, right? But if these 3 points are not collinear, let's take a situation where these 3 points are not collinear, right? When you let's say join these two and these two and these two, now you see, let's say this point is A, this point is B, this point is C. Now these 3 points are not collinear, we have taken the points like that. Now you see these 3 points are making a triangle here, right? And in any triangle, distance, sum of distances of any two sides is greater than the third side. AB plus BC is greater than AC, right? Only then you can form a triangle. If sum of any two sides is greater than the third side, only then the triangle can be formed, right? So in this case, these 3 points are not collinear, right? So for the test of collinearity, we can write that for 3 points to be collinear, let's say, let's write it like this: for point A, B, C to be collinear, distances AB plus BC should be equal to AC, right? And in this case, it will not form a triangle, right? Otherwise, if these are not collinear, these 3 points will form a triangle, right? So this is the test of collinearity. Here we can write the second result also. If you need to prove that any 3 points form a triangle, then you just need to show that sum of any two sides is greater than the third side, right? For example, this case, AB plus BC is greater than AC, right? And similarly, AC plus AB will be greater than BC, and the third situation also. So any two sides, sum of any two sides will be greater than the third side for 3 points to form a triangle, right? So these two results you have to take care of. Let's look at other things. Let us say we need to prove, if we are given let's say 4 points, okay, and the question is what kind of quadrilateral these 4 points form. You just join these points. You don't have to draw these points, right? I am joining these to make it visual to you, right? So that you can visualize what is happening here. Let's say these points are A, B, C and D, right? So what kind of quadrilateral is this? For example, if I can prove AB is equal to CD and AD is equal to BC, the opposite side, pair of opposite sides is equal. This is equal to this and this one is equal to this one. Then I can clearly say that this quadrilateral is a parallelogram. right? In the class 9th you studied that if the pair of opposite sides is equal, then that quadrilateral is a parallelogram. And the next result we can write is, if let us say we have shown that the pair of opposite sides is equal. Now if we can show, first we have shown that pair of opposite sides is equal, right? Now if I can show that diagonals are also equal, then what I can say is that quadrilateral is a rectangle, right? In a rectangle what happens is the opposite sides are equal, right? And this much was sufficient to prove a quadrilateral as a parallelogram, right? But now if I can prove that these diagonals are also equal, this diagonal is equal to this diagonal, then this will surely be a rectangle, right? And let us say you are given 4 points again, right? Let's say these points are A, B, C, D. If you can prove that the distance AB equal to BC equal to CD is equal to AD, then you can say that quadrilateral is a rhombus. What is the property of a rhombus? That all sides are equal, right? And when does a rhombus become a square? If I can prove that all sides are equal, also the diagonals are equal, diagonal AC and diagonal BD are equal. This is the first condition. And secondly, I need to prove AC is equal to BD. Collectively these two conditions will tell me that this quadrilateral is a square, right? Because all sides are equal and diagonals are equal, right? So in a square all sides are equal and diagonals are equal, right? So it will become a square. Let us look at equilateral triangle. Equilateral triangle is very easy to prove. All the sides are equal, right? Let's say we are given these 3 points A, B and C. If we can show that AB is equal to BC is equal to AC, then we can say that triangle ABC is equilateral. For isosceles triangles, for triangle to be isosceles, we need to show that any two sides are equal. For example, let me take this triangle here. Let's say this is C, this is B, this is A. Okay, if we need to prove whether a triangle is isosceles or not, what we have to do is, let's say this is the triangle, right? We need to prove any two sides as equal. For example, if BC is equal to AC, right, and it is not equal to AB, then we can say that this is an isosceles triangle. Or for that matter, any two sides. For example, this side can be equal to this side, right? You just need to calculate these distances AB, BC and AC, right? If any of these two distances is equal, then you can say that the triangle is isosceles, right? So these are some of the usages of distance formula, right? We will be given some points and we need to prove whether they can form a triangle or not. When would you say that they can form a triangle? When sum of any two sides is greater than the third side, then you can say that these 3 points are making a triangle, right? When would you say that these are collinear points? When sum of the two distances is equal to the third distance, then those points are known as collinear points, right? And you can prove various types of quadrilaterals and triangles, right?